In our video number 13, we are going to learn some more methods of classification of data. Here we have the statistical series. The statistical series classification, we have a number of them. The first one being on the basis of the characteristics. And of them, the first is the time series, which is based on the basis of time, that is historical dates. So 1881 the first census was conducted, 1947 India became independent, and so on and so forth. Then the next one is spatial series on the basis of location. Location meaning the geographical location, like Asia or America or Europe and others. So they are all dependent on the geographical location. So that is called the spatial series. The third one being the condition series, that is based on the conditions. What is the condition here? Age group, weight, height, wages, anything. So that is the conditional series. The next one is based on the construction. Based on construction, we have individual series in which we have individual observations. And the data that is collected at first is called the raw data, and this raw data is very unorganized. Once you arrange this raw data either in the ascending order or the descending order, we call it the organized data or an array. For example, marks of students and wages of labor. We'll first see what this raw data looks like and how can we arrange it or organize the data. Let's say we have a question, marks of 25 students is given, represent as frequency array. So we have these marks of 25 students, this is called raw data because the marks are like 20, 15, 20, 30, 40, 25, 25, 30, 40 and so on and so forth. So once this data is arranged either in the ascending order or in the descending order, you call it the array. So let's say here 15 is the lowest mark, followed by 20 and then 25. So if you arrange them in the increasing order or ascending order, we have 15, 20, 25, 30, 35, 40, 45 and 50. So this can be called as an array. And since we are talking about the individual series and that the marks of the students are individual, isn't it? So let's say a student with roll number 1 scores 20, roll number 2 scores 15, roll number 3 scores 20, roll number 4 scores 30, roll number 5 scores 40 and so on and so forth. So this is individual because these marks belong to only roll number 1. So roll number 1 has scored only 20 marks. So this is his individual mark. Hence the series is called the individual series. Let's now talk about the next series called the discrete series. In the previous video, we learned what is a discrete number. A discrete number is a whole number, isn't it? It is not a fraction or decimal. So discrete series is for an ungrouped frequency distribution. We are going to see the classification of such a data is called as the frequency array. Now array we learnt it is in the ascending order or the descending order. Then a discrete variable is that variable which takes a definite integral value and not fractional values. So they are not decimals, they are not fractions, they are whole numbers. And to represent this frequency, we can use tally marks or bars, which you must have learnt in your previous classes. Let's take this example of marks of 25 students, which have to be represented as frequency array. Now we have these marks and we need to arrange them as a frequency array. So the first step over here is to arrange these marks in the ascending or the descending order. Let's opt for ascending order because it's easier. The lowest being 15 followed by 20, 25, 30, 35, 40, 45 and 50. Now we are going to see how many times these marks have occurred and use the tally bars for the same. So how are we going to mark this? You know how to mark this. 20, we'll put a bar here. Then comes 15, so put a bar here. Then 20, a bar here, and so on and so forth. So you know how to do that. And once you have 4 bars together, the 5th bar will not come here. Instead, you will strike out the 4 bars and make a bundle of 1. So each bundle will have 5 bars. Why do we do this? Because this makes counting easier. Now, how many times have these bars occurred is given by the frequency. Here, 15 marks have occurred thrice, and so the frequency is 3. Similarly, 20 marks have occurred thrice, and so the frequency is again 3. Now, 25 marks have occurred 4 times, so the frequency is 4, and 30 has occurred 5 times. This is a bundle of 5, and so frequency is 5. Similarly, 35 occurs 2 times, 40 occurs 4 times, 45 is occurring only once, and 50 occurs thrice. When you add up all the frequencies, you get the total number of students. So if the total number of students matches with this, that means your calculation is correct. And your frequency array is totally true. The third statistical series is the continuous series, otherwise called grouped frequency distribution. What is a continuous series? It is a series that represents continuous variables showing range of values of different items of the series, which are expressed in class intervals, that is with class limits, and they are framed without any break. Here, continuous variables are those variables which can take decimals and fractions also. So, in the previous video, we learned what is a continuous series, in which suppose you have 10 to 20. Remember this? 10 to 12. I think 10 to 12. So, all the variables from 10 to 12 were used. 10, 10.5, 10.1, 10.2, 10.3, 11, 11.1, 11.2, 11.3 up till 12. So, all fractions, all decimal values will be included in continuous series. Now, we said that they can be arranged within the class limits. So, what is a class? A class is a group of numbers in which items are placed. Suppose we have a class from 0 to 10. So, this is from 0 to 10, all the items can be placed within this range. Then, you may continue writing the class intervals as 10 to 20, 20 to 30 and so on. The lower class limit is on the left hand side of the class, and the right hand side one will be called as the upper class limit, represented by L1 and L2 respectively. So, what is a class interval? Class interval is L2 minus L1. That means upper class limit minus lower class limit. Here it becomes, let us say if you take this one, then 20 minus 10 equal to 10. And the other one, 10 minus 0 equal to 10. So here the class intervals are equal. Class interval represented by letter C or sometimes I also. Then what is a range? Range is the difference between lower limit of the first class interval and the upper limit of the last class interval. So suppose we have class intervals 0 to 10, 10 to 20, 20 to 30 and 30 to 40. Then the lower class limit L1 of the first class interval will be minus L2 or the upper class limit of the last class interval. So what is the lower class limit of the first class interval? 0. And what is the upper limit of the last class interval? This is the last class interval. and the upper limit is 40. So 0 minus 40 or 40 minus 0, whatever, gives us 40. So 40 is the range of this particular series. Now the next one is the midpoint of the class interval. Midpoint means the central point of a class interval or the middlemost item of the class interval. For a class interval 10 to 20, the midpoint will be given by the sum of the lower and the upper limits divided by 2. For this class interval, the lower limit is 10 and upper limit is 20. So 10 plus 20 by 2, which happens to be 15. So 15 is the midpoint of a class interval 10 to 20. Now the next thing that we have to learn here is frequency. This we have come across in the previous video also. It is the number of items or observations falling within a particular class between, let us say, between 10 and 20. If 15 students have scored marks, then the frequency is 15. So 15 students have scored marks between 10 and 20. Also, class frequency of the class 10 to 20 is 15. This way also we can put up. The sum of the frequencies will be given by sigma f or capital N. You have frequencies, let us say, we'll take a previous example. Let us say from 0 to 10, 10 to 20, you have some numbers 1, 2, 3 and 4. You add them up, 4, 5, 6, 7, 8, 9 and 10. So, this is the sum of the frequencies represented by sigma f or n. Then we have frequency distribution. We have come across this also in the previous video where we said frequency distribution is a tabular representation. So it's a table that shows class intervals with corresponding frequencies. So let's have a table of class and frequency. So we have class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, and frequencies, how many times the values are occurring. Between 0 to 10, the values occur 4 times. Between 10 to 20, the values are occurring 5 times. And between 20 to 30, the values are 3 times. And the values between 30 to 40, they occur 3 times. Now the sum of all the frequencies is given by sigma f, which is also equal to capital N. And sum it up, you get 15. So this is the total of the frequencies. This table that shows class intervals, their frequencies and the sum of the frequencies is called the frequency distribution.